Hey girls, today we're going to look at taking the square root of variables. So it's a simplifying square root. We're still in 8.2 in your textbook, but now we're going to add variables to our lesson from yesterday. So let's start back over, grab your pencil and paper, and let's make a list of all the perfect numbers. 1 times 1 is 1, 2 times 2 is 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. Okay, so these are a list of perfect numbers. So what we're going to look at, and I kind of in my girlfriend terms call the radical a jail. And I say the way to get out of jail is to either be perfect, be one of these numbers, or to have a friend. And so what I mean by that is anytime, if I talk about as long as you have a friend, as long as you're an even number, everybody has a friend, you can get out of the jail. So let's just look at for a second. If I ask you what the square root of x squared is, then hopefully you would say that's just x. If I ask you what number times itself gives you x squared, what if I said what's the square root of x to the 6th power? Hopefully in your mind you're saying, oh, times that is x to the 3rd, because remember, 3 plus 3 is 6, and so x to the 3rd times x to the 3rd, when we're multiplying like bases, we add the exponents, that's an x to the 6th. So x to the 3rd times itself gives you x to the 6th. What if I ask the square root of x to the 20th? Hopefully you would say, oh, Miss Himes, that's x to the 10th. And you can see essentially if it's an even number for your exponent, you really are just halving it. That's what you can see. What happens is sometimes we don't have an even number. And this is when I'm going to have to train you to do something that I never would say to do in real life, and that's you're going to leave somebody out. So what we're going to do, if I ask you for the square root of x to the 9th. Well, yesterday, using the product rule, we learned that that is the same thing as the square root of x to the 8th times plain old x. So notice what I've done. I've left one x behind, and I've factored out the other 8 that are there. So I have 9 total, but 8 all have a friend, and then the poor little lonesome one is left there. Well, what's the square root of x to the 8th? Well, it's x to the 4th, and then I'm left with this plain old x. And this is what we call simplifying radicals when we're dealing with variables. So essentially, if it's an even number of the exponent, then you just half it. If it's an odd number, you take one out, subtract one from the exponent, and then half that number. So let's look at example 4 up here. So this again is in your textbook. You can resource this. You look at this as a resource from your textbook later. So x to the 3rd is not even. I can't half that. But it is, if I take one out, it's x to the 1st times x to the 2nd, right? And then my product rule says that's square root of x to the 2nd times square root of x, and square root of x to the 2nd is x. So in simplified form, that's just plain old x times the square root of x. Do you see what I'm talking about? I'm going to erase this over here for a second. I'm going to leave my perfect squares over there because we're going to use those in a minute. And then we'll look at example B. I'm going to change color. So example B over here is the square root of a to the 9th. Again, 9 is odd. It is not an even number, so I can't half it. But I can take one out, leave this one behind, and do the square root of a to the 8th. Well, square root of a to the 8th is a to the 4th, and then I'll leave that plain old a left. And this is what we call simplifying radicals. Okay, if you need more practice, go look at your textbook, and there's some drop-down online textbook. There's some drop-down examples that would be great for you to practice. We're going to move on to example 5. And in example 5, now we're going to have to look back at what we learned yesterday and then deal with what happens if there's a number already situated on the outside of this radical. So, yesterday we looked at 27 is not perfect, so it's not one of these perfect numbers. It has no ticket out of this jail. But there is a perfect number that goes into 27. What is that? Hopefully you said 9, so I could look at this and say this is 9 times 3 times m. All of this is still underneath the radical. Yes? 9 is perfect, and so I could circle it, or I might just do a little highlight and give it a highlight. It can come outside the radical because it's perfect. So like I said at the beginning, if it's perfect or it has a friend, it has a ticket out. So the 9 outside the radical becomes a 3. but there is a 4 outside the radical. So what I'm going to do is I'm going to multiply 3 times 4 and get 12, and then I'm going to leave behind the 3 and the m. So that's simplest form of this example 5. Factor out a perfect number, 9, take the square root of it, and then multiply by that number on the outside, leaving 3 and m. M has no ticket out because it doesn't have a friend, it's not an even number, and it's not a perfect number. Okay, I'm just going to keep rolling through. I'm going to do these next 2 examples, and then your homework this time is going to be on WebAssign. So hopefully there's tutorials there. There's great tutorials in your textbook if this is not enough for you. But let's look at, I'm going to go back to my blue color with A. 144, perfection. So this has a ticket out right there. It can become a 12 on the outside, but a to the 7th is an odd number. So what do I do when I have an odd number? Well, I leave 1 behind, and then I make it an even number. So the square root of 144 is a to the 7th is a to the 6th times a, and then 144. And what you might want to do, and this is what I'm just going to highlight here, this has a ticket out, and this has a ticket out. This is perfect, and that has a friend. So when they come outside the radical, 144 becomes a 12. A to the 6th becomes an a to the 3rd, because a to the 3rd times a to the 3rd gives me a to the 6th, and then I'm left with radical a. And that's how I would simplify example A of number 6. Switching colors, and again, slow this down and repeat if it's going too far. What if I have 1/6 square root of 72 x to the 5th? Well, I've got situations here. To get out of jail, the 72 has to be perfect. It's not. The x to the 5th has to be an even number. Everybody has to have a friend, and they don't. So let's break it down so we can create some perfect numbers and leave 1 behind so we have an even number of x's. 72, and you may not know this yet, but you will as we keep doing this, is 36 times 2. So I'll just go ahead and tuck that in your memory. And then x to the 5th is x to the 4th times x. All of this is still in jail. And then I have a 1/6 sitting outside of jail. Okay, I'm going to highlight in my little green color, perfection. This 36. It's on my list of perfect numbers. X to the 4th has a friend. It is an even number. Both of those have a ticket outside of this jail. But the 2 and the x don't. So underneath this radical, we keep the 2 and the x. The 36, the square root of 36 is 6. So its name on the outside of this radical is a 6. Well, 6 times 1/6 is 1. So if I bring it out here and I have 1/6 times 6, everything's going to cancel, and that leaves me with a 1 out here. And then the square root of x to the 4th is x squared. So when I simplify 1/6 square root of 72 x to the 5th, this is my answer right here. And so that's how we do that. Again, look at your textbook online. There are more videos to watch, and give your WebAssign a go, and you can look at help sessions there. Hopefully this was helpful, and if not, when we Zoom, bring your questions, and we will address any issues you have at that point.